Hello YouTube, welcome back to my channel. So in today's tutorial we are going to go over the KNN algorithm. So we'll look at what KNN is, and then if you don't know what KNN is, we'll look at it just shortly. It's just a machine learning algorithm. Okay, so this is just a continuation of our machine learning series that we began earlier. So in this tutorial we're going to look at the KNN algorithm. So what does the KNN stands for? So KNN is an abbreviation for which stands for K nearest neighbors. Okay, so this is just a machine learning algorithm that uses used for classification problems. So when a KNN classifier is given data points based on how it classifies data points based on how its nearest neighbors are classified. So it's a lazy learner. Now if you're not a lazy learner we'll look at this we'll look at that in the next in this slide. Okay, so it is also a non-parametric model, meaning that no pre-assumptions are made before the data is data on how the data will be distributed, unlike other models like logistical models and linear models where the data has to be in a certain shape and distribution, right? Okay, so it does not really follow, it deals with data that does not follow any kind of mathematical theory or patterns, stuff like that. So this is what this kind of model is used for. So how does the KNN work? So basically how the KNN works is that it classifies data points based on the votes taken the votes of its K nearest neighbor. So K is just a number, just an integer. So if K is 5, right, then it will take votes based on its 5 nearest neighbors. Now we'll look at this in more details as we go along, but one thing that you have to know, that the K must not be too small or must not be too large. We'll look at this, we'll deal with this more in this tutorial. So K should be a number, it shouldn't be a number like 1 or 2. That will make it a bad model, and it should also not be very big, since the classes that have the smallest data set will always be at a disadvantage. Okay, have a smaller amount of data set will always be at a disadvantage. So how do we select the K nearest neighbor? So how we do this is that basing on the proximity, how the data is close to the data points. I'll show this just in a graph. So for example, I have this graph right here, right? So I have these samples, the red, the orange ones, that have been classified into, let's say, class A, and then the light blue ones have been classified into class B. Now we have a new point here. Imagine you're making a predictions, right? And this data point was your prediction, and it was right here. So how do you classify it? So what we do is that we measure the distance to the nearest, to all the nearest neighbors. For example, you can see this distance, all the nearest neighbors are this one. Okay, so we measure these distances between the lines, right? We measure these distances, and then we take the distances of the 6 most closest neighbors. We take the distance of the 6 most close neighbors. So basing on that, we will take a vote. So for example, let's say the radius of the 6 most closest neighbors is this cycle, right? This dotted cycle, right? Where K is 6, because we are considering only 6 nearest neighbors, which is 1 2 3 4 1 2 3 4 5 and 6, right? So that's K. So we take this the distance, and then we measure which within this radius, which class appears the most, right? We take a vote, which class appears the most. So in this case, we have 3 blue ones, light blue ones, and then we have 2 orange one. So what we'll do is that we'll classify this model as, this data point as belonging to the blue class, since out of the 6 nearest neighbors, right, 3 of them vote to be blue. So the blue vote is more than the orange vote. So this data point to be classified as the class B, which is the blue class, right? So that's how a KNN works. So that's basically how a KNN works on a basic level. So how do we calculate these distances? We can calculate these distances based on different things. So like you can use the Euclidean distance, the Minkowski distance, the Hamming distance, and then the Manhattan distance. So you can use different mathematical methods to calculate the distances, and the distances are just basically these the lines, right? So that's what the distances are. So basing on these distances, we can take the votes. We take the 6 closest distances, 6 closest data points, and then basing on that, we can take the votes basing on which class most of the closest neighbors are. So that's how K nearest neighbor stands for. Hence the name of the algorithm, K nearest neighbors. In this case, 6 nearest neighbors, right? So that's how basically a KNN works on on the surface level, right? So let's look at what we talk about. We call the model KNN a lazy learner, right? So what's a lazy learner? A lazy learner is a model that doesn't train the data during fitting. It just takes the data and store it in memory. The only times it uses the data is when you're making a prediction. It loads the data into memory and then does a comparison. For in this case, you can't really train this model, right? You can't really train because you're just plotting the data, you're just putting the data in memory and then measuring the 6 closest neighbors. So you really can't train this model. So that's what is called a lazy learner. So a lazy learner is just a model that doesn't train during fitting of the model. It only loads the data into memory when making predictions. This makes it very expensive. So whenever you are building a model, maybe that will be online and has a very huge data set, the best thing to do is not to use a lazy learner, because it have to load this data set into memory every time a person wants to make predictions. Imagine you're building an API. This will take a lot of time and computation, right? It's very expensive. So the opposite of lazy learner is eager learner. So eager learners will train the data, will actually train doing the fitting of the data, will actually train, like for example, logistical model, and all the models that you have looked prior to this video in this series are all eager learners, because they train before making the predictions. They don't do the training during the prediction time. Okay, so that's what an eager learner is, and that's what a lazy learner is. And KNN is one of the lazy learners. Okay, so when do you use a KNN? So you use a KNN when you have a label data, because you need a label. You also need to use the data needs to be noise free data, and then it works very best with small data set. For example, about 1 gig of data it can work it, but anything above 2 gig, 3 gig, the model can be computationally very expensive. And also since it's a lazy learner, that's why it can be computationally very expensive making predictions. Okay, so the data set with also, we can also use this when you have data set with less dimension to avoid the dimensionality curse and overfitting. So if you don't want the dimensionality curses, you can obviously read about dimensionality curse and how it affects the KNN. Okay, so now that's all the basic theory of KNN, how it works, how it's a lazy learner, how various methods of measuring the distance, Euclidean distance, mean Kioski distance, and this is how it basically works on the surface level and stuff like that. So now that you have looked at all of this, let's jump into the coding section and let's begin to code. So now that you have done that, we've already gone over the theory, let's go ahead and actually begin to code. So we're going to import the necessary libraries, and then we'll load in our data set and we'll begin to do the process. So I'm going to be using the iris data set. So we're going to be using this data set. So this data set is actually a very simple and clean data set. The reason why we are using this data set is that it's simple and helps you to understand the concept, right? So this data set is just data set of the iris data, very famous data set in machine learning and data science. So this this data set consists of the various classes of the iris flower. So the iris flower, there are 3 main classes. There is iris setosa, there is iris virginica, and then there is iris versicolor. Okay, I hope it's pronounced like that. So these are the 3 main classes of the iris flower. So we're going to classify this. So we're going to create a model that to help us to classify based on the sepal length, the sepal width, the petal length, the petal width, and stuff like that. So that's what we're going to do. So this data set might look simple, but I'll give you a new challenge on my GitHub page. I have a Jupyter notebook in there, and it has a data set for predicting diabetes. So you can go ahead and actually, I will leave the link in the description below. If I forget, someone can remind me in the comments, so that you guys can practice working with this data set to predict diabetes, if a person will get diabetes or not, using the Sklearn algorithm. Okay, so let's get started. So the first thing I'm going to do is that I'm going to import in our data, right? I'm going to import the necessary libraries that will help us to import our data. So I'm going to go import numpy as np, and then I'm going to import pandas as pd, and then I'm going to write that. So we're going to store our data frame in df. So I'm going to do pd.read underscore csv, and I'm going to pass in the path to the csv. So I store it in data sets, and then it's called iris.csv. So I'm going to run that, and I'm going to df.head just to see the first 5 rows. So you can see this is our iris data set. So now this is the iris data set. Let's go ahead and actually remove the stuff that we don't need. So let me go ahead and actually drop the id column. So I'm going to df.drop, and I'm going to pass in the id. It's called id, and then I'm going to say axis is on the 1, it's on the column, and then I'm going to say replace equals to true. Okay, if you don't know about this pandas, I have a also series on pandas on my YouTube channel, and you can check that out. Sorry, this is actually in place, not replace, in place. Okay, so I'm going to run that. So if you want to know about pandas, you can check my tutorial on pandas. So what you're simply doing here, you're going to drop the ID column is on the row axis. That's why axis equals to 1, and you're going to, sorry, on the column axis, and then you're going to say in place equals to true. In place means that it will do the reassignment for us back to this variable. Okay, so I'm just going to do df, and then I can see we have the ID column has been dropped. Okay, so one thing you can also see is that we have on the species, right, we have the species column, right, and it is textual data. Now machine learning models do not understand textual data, so we need to encode this. So we're going to use label encoding, and you're simply going to replace the text with the numbers, right? So we're going to encode them. So let's, for example, I'm going to do df, and I'm going to get the species column. Since you want to encode the species, I'm going to let me show you get the spelling right of species, and then we're going to do df, and then we're going to replace this. We get the species columns, the species, and then you're going to do a replace. So the replace in here, I'm simply going to pass in a dictionary. Okay, now before I do that, let me create a cell above here, and I'm going to get I'm going to do df, and I'm going to go to the species column, and I'm going to get all the unique values from there. So to do that, I'm just going to say unique, and then I'm going to run this. So this is going to return to us all the unique values from the species column. And then I know there are 3 main classes: Iris setosa, Iris versicolor, and then Iris virginica. So those are the 3 main classes. So we're going to encode this. We're going to encode Iris setosa. You're going to encode it with a value of 0, and then you're going to encode Iris versicolor with a value of 1, and then you're finally going to encode this to be 1, and then you're finally going to encode the Iris virginica with a value of 2. So I hope I'm pronouncing these things right. So no, I put this here. So now I'm going to run this, so we can run our cell again, and then we can do the df, and then let's just do df.head. Just that we can see the first 5 rows. So now we can see the first 5 rows of our data, and we can see our value has been label encoded. Previously this was setosa, it has been encoded to 0, so now it has been replaced with 0. Similarly, all the others will be replaced. So if I can do df.tail, and I can see now we have encoded Iris virginica with a value of 2. So now that's what we have right now. So now let's create our x and our x and the y value. So we're going to x will be df, and df you're going to x just be the everything except the species. So we df.drop, we're going to drop everything other than we're going to keep everything, sorry, other than the species column. So we need to drop the species, right? That's what I mean. And then this is on axis, which axis is 1 and 1, just like that, sorry, 1, and then I'm going to run that. This is going to return to us x. So if I do x, sorry, this is x, and then you can see we have that all the columns there except the species column. So now let's go ahead and actually create for the y. So the y will just be df the species, right? So species, just like that, and then we can do y, we can have the species column right there. So now that we have this, let's go ahead and split our data into training and testing samples. So I'm just going to go we need to import this from sklearn.model selections, right? So from sklearn .model underscore selection, you're going to be importing train underscore test underscore split, just like that. So we're going to do x underscore train, and then x underscore test, then y underscore train, and y underscore test will be equals to the train test piece. So train underscore test underscore split, and then you're going to pass in here x, which will be x, and then y, which is y, and then you're going to specify train underscore size. So we're going to use 80% for training. That's why I'm going to say 0.8, and you can also specify random underscore state. So random state will enable you to be able to repeat this. So just keep it 200. So now we have split our data into training and testing samples. So we're going to use 80% for training, and then the rest 20% for testing our model. So I'm going to do this, and then I'm going to do the shape, and you can see we have 120 there. And then I'm going to do this. I'm going to copy this, the test, and I'm going to copy it and paste it right here. And I'm going to do dot shape, and then I'm going to run that. So now we can see we're going to use 120 rows for training, while we're going to use 30 rows for testing our model. Okay, so now that we have that's there, let's go ahead and actually begin to create our model. So to create our model, we need to import this from one thing we can also do is that we can scale these values. Okay, so we can also scale these values, these large values, but the values are not very large, so in these tutorials I'm not going to scale it. But if you want your model to perform better, the best thing to do is to actually scale your values. But since they're not very large values, in this tutorial I'm not going to scale it. I'm just going to leave that as an assignment for you to see how the scaling can improve your model performance. Okay, so always remember to scale your data. Okay, scale it between 0 and 1, and then to try to create a model. You will likely get better accuracy. So I'm going to say from sklearn.neighbors, I think it's called neighbors, neighbors. Yeah, we're going to be importing import k nearest classifier. So the k nearest classifier is going to help us to classify our model. So if you go back to the official documentation about the k nearest neighbors, if you just open up their page here, this is how what you're supposed to do. So get the k nearest neighbors, and then you'll be able to providing the parameters. So by now, for now, let's go ahead and actually create the instance of the k nearest neighbors, and then we'll come back to this page and I'll explain to you. So this is actually k neighbors. So k neighbors. So k neighbors classifier, we're going to import that. So I'm going to run this, and I'm going to create a model called KNN equals to k nearest neighbors, and I'm going to pass in you need to pass in some set instances, so some values. So the first thing we're going to pass in is the number of neighbors, right? We have talked about the number of neighbors in here. So we have talked about the number of neighbors, and I explained to you the number of neighbors. For example, in this case was 6, which will be the numbers from the nearest values from which we're going to take a vote. So we can go to specify, you need to specify that in there. So I'm going to say n underscore, this is actually n underscore neighbors, so neighbors, and then I'm going to specify this to be, let's go with 6. Okay, so let's give it to be 6. Nearest neighbors is 6, and then we can also specify two values. So we can specify the matrix, which is the matrix, and the p-value. So the matrix is the value in which you want to the method which you want to use to measure distance. And I have talked about the methods being Euclidean distance, Minkowski distance, and stuff like that. So in this case I'm going to use matrix as Euclidean, since it's much computationally less expensive. Metric is Euclidean, just like that, Euclidean, and then I'm going to specify p. So the p is known as the power parameter, and for the Euclidean distance is 2. Again, you can read all this information on their website right here. So you can say for Euclidean distance for p is 2. Okay, now you can see we have that there. So I'm going to ahead and run this model. So I have an error neighbors, there is a h somewhere here, so make sure I get that right. So we have our model, right? So now let's go ahead and actually fit our model. So KNN dot fit, just like that, and you're going to provide in your x. So this will be x underscore train, and I'm going to say y underscore train, just like that. So now that we have this, and I'm going to run this model, you're going to see our model has been trained with the nearest neighbors of 6 and a matrix of Euclidean. So now that we have that, we can go ahead and actually begin to make predictions. So I'm going to do a simple prediction to predict our settings, to predict a certain variable. So I'm going to go I'm going to get x underscore test. You're going to get the first one. I'm going to get the very first one. So I'm going to run this. So I got an error, says that okay, x test, this is actually a data frame. So I'm going to run this, and then I'm going to get let's try to get the head only, dot head, and then let's choose any value from here. So I'm going to do KNN dot predict, and I'm going to predict this of the first row. So we're going to say that the sepal length is 5.5, so 5.4, sorry, and then the sepal width is 3, and then the petal length is 4.5, and then the petal width is 1.5. So if you run this, we actually need to, and it has an no attribute predict, so this actually predict. So run that. I think this should be 2 dimensions, so let me just make it to be 2 dimensions like this, and also keep this here. So if you run this, we get our prediction to be 1, and then we can go back to the testing, and then we can check if it's actually 1. So we're going to do y underscore tests, test dot head, So we run that, you can see it's actually 1. So our model got the prediction correct. So now let's go and do some evaluations on our model. So you can try in different values. You can go on the field or the internet and collect data about the iris classes, and then you can pass it in here, then you can predict which class it is. So this one, the prediction is 1, and you have encoded 1 with iris versicolor. So this actually happens to be an iris versicolor class of iris flowers. So now that we have that, let's go ahead and actually do some evaluations running confusion metrics and be able to check the model accuracy. So I'm going to do from import this from Sklearn metrics. You're going to be importing this is actually confusion metrics, confusion underscore metrics, and I'm also going to import accuracy underscore score, and I'm also going to importing classification underscore report, just like this. So if you run this is going to import for me this library. So now let's go ahead and actually create a confusion matrix. But before we do confusion matrix, let's get the predictions of all our test files. So predictions, we're going to do knn.predict, and I'm going to pass in here our x underscore test. Just like that, you're going to get our predictions. So we're going to have our predictions here. So if I do predictions, this is going to be a list of numbers, and you can see these are predictions, right? So now let's pass this create a confusion matrix. So we're going to do cn. I'm going to call it confusion matrix. So it is going to be confusion. Yeah, this is confusion underscore matrix. And then I'm going to pass in 2 things: the truth value, which is the y underscore test, and the predicted value, which is the prediction. So we're going to pass in that. So predict, let me call it predictions, makes more sense, predictions. So run that, and then this should be also be predictions. Run that, and then this should be predictions as well. So if you run that, you're going to get a confusion matrix, and this is how our confusion matrix looks like. So now let's go ahead and actually import Seaborn so that you can be able to visualize this. So I'm going to say import Seaborn. It's actually Seaborn as SNS, and then I'm going to run that cell. So I'm going to import Seaborn. Let me just go ahead and actually import also math. Let's say from matplotlib import pyplot as plt, and then you're going to run that. So we have those 2 libraries to visualize data. So this will just allow us to visualize our confusion matrix. Okay, so let's go ahead and actually try to visualize it. So I'm going to do something here. I'm simply going to say importing this library. So you have to create a confusion matrix. So I'm going to create a figure, so plt.figure, just to make our graph. So I'm going to say fig size. And then if you don't know about Seaborn, I have a series on Seaborn on my YouTube channel. You can go and check that out. So I'm giving it the dimensions, and I'm going to go Seaborn.heat map, and then I'm going to pass in our confusion matrix, and I'm going to say a not equals to true. So a not equals to true just allow us to see the numbers, and I'm going to say plt dot x label. So the x will be our prediction, so we're going to call this predictions, and then also we are going to do a plt dot y label, which has to be the truth, and then you're also going to give it a title, plt dot title. You're going to say confusion matrix like this, and then you're going to do a plt dot show. So plt dot show. So if you run that, it's going to plot our graph for us. We got an error. Let's see, plt has no attribute x label, so this is actually like this. And then if you run that, we got plt. So I made an error, sorry guys. So this plt, this one here is actually an error, plt, and then I run that, so we don't have any error. We can see we have our graph right there. So you can see these are the truth values, right? Truth values, and these are the predictions. Okay, and you can see that this is the main diagonal, and on the main diagonal we have all our values, which equates to 30, and then on the non-main diagonals we have 0 all the way. This means that our model was able to classify each data point very accurately. So this is actually very amazing, even though our data is very small, but you can see the accuracy is just very large. So in here you can also make this font larger and stuff like that. So you can say font size, let's say font size of 18, and then we can run that. So I got an error. Is it font size? Okay, there's one just like that, and you can see we have the confusion matrix right there. So you can go ahead and actually play with these graphs and stuff like that. I have a whole series on data visualization on my tutorial on my YouTube channel, so you can go ahead and actually check accuracy. So imagine, remember we imported accuracy underscore, so you're going to use that in here and then you're going to pass in the truth value, which will be y underscore test, and then you're going to pass in the predictions. So if you run this, we have an accuracy of 1, which is 100% accuracy, and this is also an evidence from the confusion matrix. And I have a whole series on how to evaluate the confusion matrix on my YouTube channel in this machine learning series, so you can check out how to make sense of this confusion matrix. So you can see our model is actually doing well. So you can also, there's no need to even do a classification report, but a report, but let's just do it. So classification report, I can type report. Okay, we're going to pass in y test, and then we're going to pass in predictions. So we're going to pass that in, and then you're going to print it so that the output can be nicely formatted. And then I'm going to bring that also here, and if I run this, you're going to get predictions. This actually come here, and then we have the predictions right there. So you can see everything is just up to 100%. So this is just a perfect model. So we don't even need to scale it, but for better performance, because it's just a small data set, I try to scale the data and then see how it performs. But you can see our model is doing quite really well. Precision is 100%, recall is 100%, F1 is 100% for all classes. If you don't know what this F1 precision and recall are, you can check the video on how to evaluate the confusion matrix. We went over all of this in that tutorial. So okay guys, I hope you don't have any questions on how to evaluate a confusion matrix and other stuff. You can check the videos out. If you have any question on how to other parameters, you can always check the official documentation, and there is many parameters that you can provide to improve the performance of your model. This is just a small data set, so if you have a larger data set, your accuracy won't always be 100%. In fact, it's actually rare that you get an accuracy of 100%, right? So yeah, this is all I wanted us to talk about in this tutorial. If you enjoyed this tutorial, give it a thumbs up, subscribe to my YouTube channel for more informative videos like this on machine learning, data science, Python tricks, and just Python programming in general. So if you like this tutorial, give it a thumbs up and subscribe to my channel, guys. It takes a lot of effort to make these videos. One of the ways you can support my channel is liking this video and hitting the subscribe button, and that's all I ask of you. Thanks for watching. See you in the next tutorial. Again, if you want to practice, you can find this link in the description, and you can practice on how to predict diabetes using the KNN model. So that's all for KNN for today. So thanks for watching. I'll see you in the next tutorial. Keep safe.